There is a phrase attributed to Albert Einstein that has circulated on the internet for decades as a chilling warning. If the bee disappeared from the face of the earth, man would have only 4 years left to live. No bees, no pollination, no plants, no animals. No animals, no humans. Historians have debated for years whether the physicist actually said those words. Probably not. The quote does not appear in any of his writings, nor in his letters, nor in preserved recordings. And yet the phrase has spread with such force that millions of people repeat it as if it were scientific gospel. There is something revealing in that. We needed to attribute it to someone like him, to the most celebrated mind of the 20th century. Because the idea itself is so unsettling that we only dared believe it if it came signed by a genius. The paradox is that, whether or not Einstein said those words, modern biology confirms that the warning was not far off. Perhaps not exactly 4 years, perhaps not the total extinction of our species. But yes, a food, ecological, and economic collapse of proportions that are hard to imagine. And what is truly disturbing is not what would happen if bees disappeared tomorrow. It is that they are already disappearing today, as you read this, in hundreds of thousands of hives scattered across the planet. But before we talk about the apocalypse, let me introduce you to the protagonist of this story. Because the bee is not what you think it is. It is not just a yellow insect that buzzes in the park and sometimes stings. The bee is one of the most sophisticated, most ancient, and most decisive creatures that have ever existed on this planet. A creature that has been perfecting itself for more than 100 million years. That builds cities without architects. That makes decisions without leaders. That produces a substance that does not rot in 10,000 years. And that, without knowing it, holds in its tiny yellow legs something resembling the destiny of human civilization. This is its story. It all began long before the dinosaurs went extinct. About 100 million years ago, in the middle of the Cretaceous, when the Earth was an unrecognizable world covered in humid forests and colossal reptiles, there was a wasp. A hunting wasp, aggressive, carnivorous, that pursued other insects to feed its larvae. One day, we do not know which, we do not know why, something extraordinary happened. Some of those individuals began to collect pollen instead of prey. Perhaps it was an accident. Perhaps a minor mutation slightly altered their food preferences. Perhaps the flowers, which were barely beginning to appear in the world, offered a deal too convenient to refuse. That tiny shift changed everything. That wasp became the first bee. And from that moment on, the flowers of the planet were no longer alone. What followed is one of the longest and most productive relationships in natural history. Flowering plants and bees signed a tacit biological contract that they have been renewing without interruption for 100 million years. Plants invented nectar as a reward, a sugary fuel manufactured specifically for pollinators. They developed vibrant colors, elaborate shapes, complex perfumes, not for us who arrived much later, but to attract bees. And the bees in turn were sculpting an increasingly perfect body for that work. Take a moment to look closely at a bee. You will see an incredibly refined harvesting machine. Its tongue, called the glossa, is long, hairy, and ends in a microscopic spoon designed to extract nectar from the deepest corollas. Its hind legs carry rigid-haired baskets called corbiculae, where it transports pollen packed with goldsmith-like skill. Its abdomen has glands that secrete wax, the material with which the entire city is built. And its compound eyes perceive the ultraviolet spectrum, a visual dimension completely invisible to us, in which flowers project patterns that function as fluorescent landing strips. A bee does not land on a flower by chance, it reads it. It knows exactly where the nectar is before landing, guided by signals that your eye will never see. But individual anatomy is only half the story, because the bee does not live alone. And this is where the story becomes truly fascinating. A typical hive houses between 20,000 and 80,000 individuals. And those individuals are not simply a crowd of insects sharing a roof. They are, in a deep sense, a single organism. Biologists call it a superorganism, and the word fits perfectly. Just as your body is formed by trillions of cells cooperating to keep you alive, the hive is a being made of tens of thousands of bodies functioning as one. At the center of everything is the queen. And here it is worth dismantling one of the most persistent myths about bees. The queen does not rule. She does not give orders. She directs nothing. She is not a monarch. She is a reproductive factory. Her only biological function is to lay eggs, and she fulfills it with absolute dedication. Up to 2,000 eggs per day, one every 40 seconds for several consecutive years. Her power comes not from authority but from chemistry. She constantly releases signals called pheromones that maintain group cohesion, suppress the reproduction of workers, and communicate to every member of the hive that everything is fine. When the queen dies, those pheromones fade and something remarkable happens. The workers do not panic, they reorganize. Within hours, they choose a young larva, genetically identical to any other worker, and feed it exclusively with royal jelly, a substance produced by special glands in the heads of nurses. That privileged diet activates genes that would otherwise have remained dormant. The larva develops differently, larger, with functional ovaries with a potential life of years instead of weeks. A new queen is born not by lineage or destiny, but by nutrition, pure biological democracy. Workers are all female and form the backbone of the hive. But what is fascinating is that they do not always do the same thing. Throughout their short lives, barely 4 to 6 weeks in summer, each worker changes profession several times according to her age. In the first days, she cleans cells and cares for larvae. Then she produces royal jelly and feeds the young. Later, she builds honeycombs with the wax her own body secretes. Then she guards the entrance to the hive, ready to defend it with her life. And in the last stage of her existence, she goes out into the world to forage, to collect nectar, pollen, water, and resin. Each bee in 2 centimeters of body is a condensed professional career. Drones, the only males of the hive, have a dramatically different fate. They do not collect, they do not build, they do not defend. Their only reason for being is to mate with a queen from another colony. If they succeed, they die immediately after the act. If they fail, they live a relatively idle existence until autumn arrives. Then the workers expel them from the hive without ceremony so as not to waste resources during winter. There is no mercy in the hive, only efficiency. Now we come to the most cinematic moment of this entire story. Communication. Bees do not speak. They have no vocal cords, emit no articulated sounds, send no written messages. And yet they communicate with precision that would put any telecommunications engineer to shame. They do so through one of the most sophisticated symbolic systems in the animal kingdom, a code that scientists took decades to decipher, and that when they finally understood it, left the biological community speechless. The waggle dance. When a scout finds a good source of nectar, she returns to the hive and begins to move across the surface of the comb in a very specific way. If the source is nearby, less than 100 meters away, she performs a rapid circular dance that essentially means, there is something good, come out and look for it. But if the source is far away, she deploys something far more complex, the waggle dance. The bee runs in a straight line, vigorously shaking her abdomen, turns to the right, returns to the starting point, repeats the straight run, and turns to the left. She traces a figure 8 over and over again. And in that seemingly simple choreography is encoded an amount of information that seems impossible. The direction of the straight line indicates the flight bearing relative to the sun. If the bee advances directly upward, the source is in line with the star. If she advances 30 degrees to the left of the vertical, the source is 30 degrees to the left of the sun. The duration of the run indicates the distance, the longer, the farther. And the intensity of the abdominal waggle communicates the quality of the nectar. The more vigorous the dance, the richer the reward. All of this occurs in the complete darkness of the interior of the hive. The receiving bees do not see the dance, they feel it. They capture the vibrations through their legs and antennae. It is a tactile, three-dimensional language, encoded in pure movement. When Austrian zoologist Karl von Frisch first described this system in the 1940s, many colleagues refused to believe him. It seemed too extraordinary to be true. In 1973, he received the Nobel Prize for that discovery. But there is something even more astonishing than the individual dance. The way the hive makes collective decisions, especially in one of the most critical moments of its existence, the swarm. When a colony grows too large, when the population no longer fits, it does something bold. It divides. The old queen leaves the hive with half the workers and forms a buzzing cloud of thousands of bees that temporarily clusters on a branch or an eave while making a decision that will define its future. They need a new home, and they choose by voting. Scouts go out in all directions to inspect candidates. A hollow in a tree, a crack in a wall, the space under an eave. When one finds a promising place, she returns to the swarm and dances for it. Other scouts visit it, evaluate it, and if they approve, they also dance for it. The most vigorous dance, the one that convinces the most spectators, gains supporters. The defenders of the worst sites give up and join the majority dance. When sufficient consensus is reached, the entire swarm takes off toward its new home. There is no leader. There is no authority that imposes anything. It is a direct, fluid, biological democracy. And what is most surprising is that it almost always gets it right. The chosen site tends to be objectively the best available. So efficient is this mechanism that artificial intelligence engineers study it as a model for designing optimization algorithms. Bees have been practicing collective deliberation since long before Athens invented the word democracy. And now let us talk about the golden substance that has made bees famous throughout human history: honey. Because what seems like simply a sweet food is in reality a biochemical marvel that no laboratory in the world has managed to replicate exactly. It all starts with nectar. Foragers collect it and store it in their honey stomach, a second specialized stomach that does not digest the liquid but transports it. Inside that stomach, the nectar already begins to transform. The bee's enzymes, especially invertase and glucose oxidase, begin to act. When the forager returns to the hive, she passes the nectar to a processing worker mouth to mouth. in an exchange that can be repeated between 20 and 30 times. During that continuous transfer, the water in the nectar evaporates, the sucrose breaks down into glucose and fructose, and other compounds transform into gluconic acid and hydrogen peroxide. The substance is responsible for honey's antibacterial properties. Workers deposit the partially processed nectar in cells and beat their wings for hours to evaporate the remaining water. When the water content drops below 18%, the nectar has become honey. Then they seal the cell with wax and it is stored. The result is a food of extraordinary stability. The low water concentration creates a hyperosmotic environment where bacteria cannot survive. The acidic pH, hydrogen peroxide, and other antimicrobial compounds form multiple layers of protection. Honey does not expire, it does not rot. In the tombs of ancient Egypt, jars of honey more than 3,000 years old have been found in perfectly edible condition. When we say honey lasts forever, it is not a figure of speech, it is literal. But honey is not in its origin food for humans. It is the energy reserve of the hive to survive winter. A colony needs between 15 and 20 kilos to get through the cold months. And to produce a single kilo, the bees must visit between 2 and 5 million flowers. A single bee over its entire lifetime produces barely a teaspoon of honey. The next time you spread honey on toast in the morning, think about that. And here we arrive at the heart of this whole story: pollination. The most important service bees provide, and paradoxically, the most invisible to most of humanity. Pollination is the process by which pollen from the male part of one flower reaches the female part of another flower of the same species. Without that microscopic journey, there is no fertilization. Without fertilization, there are no seeds. Without seeds, there are no fruits. Without fruits, there is no food. It is a chain so elementary that we rarely think about it, yet it sustains much of what we eat. When a bee visits a flower in search of nectar, the hairs of its body, which carry a positive electrostatic charge, attract pollen, which is negatively charged. It is an almost perfect physical trap. The bee leaves the flower covered in genetic material without having made any conscious decision about it. When it lands on the next flower, some of that pollen falls onto the stigma, the receptive female part, and the circle closes. Approximately 80% of flowering plants on the planet depend on pollinators to reproduce. And among all pollinators, the honeybee is by far the most important. The figures are staggering. In the United States alone, the economic value of agricultural pollination by bees is estimated at $15 billion annually. On a global scale, pollinators contribute to food production worth between $200 and $500 billion per year. Almonds depend on bees 99% of the time. Blueberries, avocados, cherries, apples, cucumbers, squash, strawberries, sunflowers, cacao. Even cotton, which is not eaten but clothes humanity, all depend on them. The bee does not just make breakfast possible, it makes agriculture as we know it possible. And this is where the phrase attributed to Einstein stops sounding exaggerated and starts sounding precise. And then darkness arrives. In the early 21st century, beekeepers around the world began to notice something disturbing. They would open their hives in spring and find them almost empty. There were no carcasses. There were no obvious signs of disease. The workers had simply gone out to forage and had not returned. They had disappeared into thin air. In 2006, the phenomenon received an official name: colony collapse disorder, or CCD. In some U.S. states, beekeepers lost between 30 and 90% of their colonies in a single winter. In Europe, the picture was similar. In Asia, in South America, in every place where industrial agriculture had taken root, bees were dying or disappearing at an alarming rate. When scientists investigated, they found no single cause. They found a perfect storm of converging factors. The first is pesticides. In particular, a family called neonicotinoids, which are massively applied to seeds and crops in industrial agriculture. Unlike old insecticides that killed insects directly, neonicotinoids act in a more subtle and, in a sense, crueler way. They are distributed throughout the plant, including the nectar and pollen. A bee that visits a treated flower does not die immediately but suffers neurological damage. It loses the ability to orient itself, it forgets how to get home, it gets lost in some distant field and dies alone. Imagine someone administering you a minimal dose of a substance that destroys your sense of direction. You do not fall to the ground, you do not notice you are poisoned. Simply one morning, you realize you cannot remember the way home. That multiplied by millions is what happens to bees every day. The second factor is a microscopic mite called Varroa destructor. Originally from Southeast Asia, it arrived in Europe and America in the 20th century and has become the greatest biological threat to honeybees. Varroa clings to larvae inside the hive, feeds on their hemolymph, the equivalent of their blood, and weakens their immune system. It also acts as a vector for dozens of viruses that spread from bee to bee. A colony infested with Varroa is a colony that is slowly consumed from within. The third factor is more silent but equally devastating: habitat loss. Industrial agriculture has turned vast tracts of land into monocultures, immense fields of a single crop. that bloom for a few weeks and then offer absolutely nothing for the rest of the year. Bees, however, need floral diversity throughout the season. An infinite field of corn is for a bee a nutritional desert. And the margins of fields where wildflowers once grew, the natural pharmacy of the hives, have been uprooted to maximize productivity. The fourth factor is climate change. Bees synchronize their activity with the flowering calendar of plants. That synchrony, perfected over millions of years, is breaking down. Flowers open earlier than expected when bees are still dormant. Altered temperatures modify the chemical composition of nectar. Unpredictable winters interrupt winter dormancy at wrong moments. The 100-million-year biological contract between plants and pollinators is being torn apart page by global warming. And to all that we must add Nosema ceranae, pathogenic fungi, deformed wing virus, the small hive beetle, and the wax moth. The list of threats weighing on a hive today is so long that the truly astonishing thing in reality is that any colony manages to survive. But this story does not end in darkness because something slowly is changing. In Europe, several countries have banned or severely restricted neonicotinoids. France was one of the first to act. The European Union imposed moratoriums that have been expanding over the years. Farmers are discovering that regenerative agriculture methods and the maintenance of floral corridors not only benefit bees, in the long term they increase their own yields. Urban gardens around the world are filling up with plants for pollinators. Rooftops in cities like Paris, New York, and Mexico City host hot. Children learn in school what flowers to plant to help bees. Awareness is slowly changing, but it is changing. And bees, as they have demonstrated throughout 100 million years of history, are incredibly resilient creatures. A colony that receives adequate care, that has access to floral diversity, that is protected from the most harmful pesticides, can recover with surprising speed. Nature wants to survive, bees want to live. They only need humans to stop making it so difficult for them. There is a moment I want you to imagine. It is a summer afternoon. You are in a garden and a bee flies past you. Its flight is clumsy and buzzing, its hind legs swollen with little bags of yellow pollen. It is going somewhere with a determination that is nothing accidental. It carries in its body information encoded about a nectar source 800 meters away. It has in its glands the raw material for a substance, honey, that no human laboratory has managed to replicate exactly. It belongs to a society that has been functioning without interruption since before the dinosaurs disappeared. And, without knowing it, it holds in its legs an invisible link that connects almost everything you eat. That bee does not see you as a threat or as an ally. It does not see you, really. For it, only flowers in the hive exist, but you see it and now you know what it is. Not just an insect, not just a honey producer. It is a node in the oldest network of life on this planet. It is a living example of collective intelligence without leadership, of architecture without architects, of democracy without words. It is proof that evolution, given enough time and enough pressure, can produce solutions of an elegance that human engineering is still learning to imitate. And it is a living being that at this precise moment is being threatened by the same activities that make possible the civilization that allows you to hear this story. That contradiction should keep us awake at night. The next time you see a bee, do not shoo it away. Do not flee. Stay still for a moment and let it continue on its way, because it has work to do. Work that you depend on, even though you may never have thought of it that way. 100 million years of history flying in 2 centimeters of life. Whether Einstein was right or not, we may never know for certain. But there is something we can be sure of. The day the bees disappear will also be the day we discover, too late, how much we needed them. Let us not forget it.